In 1926, three German engineers in a small office in Stuttgart made a decision that would define automotive engineering for the next 100 years. They merged their companies. The result was Mercedes-Benz. Volkswagen followed in 1937. BMW had been building engines since 1916. These were not just car companies, they are institutions. They represented a century of accumulated engineering knowledge. Metallurgy, combustion dynamics, precision manufacturing, supplier relationships built across generations. 100 years of knowing exactly how a car should work. Now I want you to hold that image in your mind, because in 2003, a single year, a Chinese battery company called BYD acquired the failing car factory in Shanxi province for the equivalent of a few $1 million. They had never built a car before, and as of this week, April 2026, BYD has been just ranked the most innovative automotive company on earth by Germany's own Automotive Research Institute, the first Chinese company to ever hold that position in 20 years history of the ranking. German manufacturer Mercedes-Benz ranked third. Volkswagen, who held the top spot last year, fell to second. Germany built the benchmark for a century. China broke it in 5 years. Today I am going to show you the engineering proof of exactly how they did it. Not the political story, not the trade war story. The actual engineering decisions that made this possible and what they mean for every car you will ever buy. To understand why German automakers were so completely blindsided, you need to understand what made them great in the first place. Internal combustion engine technology, the kind that powered Volkswagen, BMW and Mercedes for a century, is what engineers call tacit knowledge intensive. That means the knowledge is not written in textbooks. It lives in the hands of machinists who have been grinding crankshafts for 30 years. It lives in the supplier relationships built over generations. It lives in the organizational memory of companies that have been making the same fundamental machine since 1886. This tacit knowledge constitutes a particular catch-up challenge for any competitor, because automotive production relies primarily on mechanical engineering, where knowledge is cumulative. Each generation builds directly on previous one. This was Germany's fortress, a moat that took a century to build and seemed impossible to cross. And here is the critical mistake that fortress created. German automakers actively resisted an early move to battery electric vehicles. Why would they embrace a technology that would make their century of accumulated combustion knowledge worthless overnight? They had the most to lose from change, so they resisted it. Meanwhile, on the other side of the world, a technology was emerging that had nothing to do with combustion engines. A technology where German's century of tacit knowledge was completely irrelevant. Battery chemistry. Here is the engineering decision at the heart of this entire story. In the 1990s, researchers at the University of Texas made a breakthrough in lithium iron phosphate battery chemistry, that is LFP. It was safer than conventional lithium ion, more thermally stable, longer cycle life, lower cost per kilowatt hour. US companies abandoned LFP technology for lack of near-term payback. Japanese and Korean manufacturers briefly explored it, then moved on. BYD looked at that abandoned technology and saw something nobody else ever saw. They saw that LFP batteries were not just a chemistry, they were a platform, a foundation on which an entire vehicle could build from scratch. Without any of the tacit knowledge that made Germany's combustion fortress so impenetrable, BYD's founder Wang Xuanfu made a decision that had defined everything that followed. Rather than licensing battery technology, contracting it out, or buying it from suppliers, they would build every critical components in-house. Batteries, electric motors, power electronics, semiconductors, software. The battery is up to 40% of an EV's cost. Wang Xuanfu said, "Our in-house control over this is our competitive edge." Today, BYD manufactures approximately 70% of its vehicle components internally, compared to roughly 46% for Tesla's China-produced vehicles. This vertical integration is not just a cost advantage, it is a speed advantage. When you own your entire supply chain, you can change it tomorrow. You don't need to renegotiate supplier contracts, redesign external interfaces, or wait for tier 1 suppliers' production schedule. You just decide and it happens. Let me give you the clearest engineering proof of what vertical integration and a software-first architecture actually produces in practice. Development speed. Chinese EV-focused automakers have slashed the time required to develop a new vehicle. Taking new models from concept to launch is roughly 24 months, twice the speed of traditional automotive companies where lead time reaches 40 to 50 months or even longer. Think about what that means. While Volkswagen is still in the design review phase of a new model, BYD has already built it, launched it, sold it, reviewed customer feedback, and began building the updated version. Chinese models on the market for an average of 1.3 years before they receive updates. Western brands average around 4 years. German manufacturers take twice as long and spend 4 times as much per vehicle development cycle. And this speed advantage has a compounding effect that traditional automakers fundamentally did not anticipate. Every 24-hour development cycle that BYD competes give them another round for a real-world data, customer feedback, and engineering iteration. While Volkswagen completed 1 development cycle, BYD completed 2. While VW completed 2, BYD completed 4. The gap does not stay constant. It widens in every cycle. There is a story that captures this better than any statistic. A Chinese-made Leapmotor was traveling down a German's Autobahn when its driver assistant braked sharply and jolted the car to the side. The driver emailed engineers in Hangzhou to report the problem before going into a meeting. By the time he got out, a software update had already been beamed to the vehicle, smoothing its behavior. A similar fix at a European automaker would have taken weeks. Executives call it China speed. It is now the global auto industry's new benchmark. Let me now show you what this engineering gap looks like in financial terms, because numbers don't lie. Volkswagen Group's operating profit fell more than 54% in 2025 to 8.9 billion as China competition squeezed margins. Mercedes-Benz operating profit fell 57% in 2025. Profits have now fallen for 3 consecutive years. BMW reported its lowest profits since the COVID pandemic in 2025, with its automotive margin dropping to 5.3%, well below its 8 to 10% target corridor. And in China, the world's largest car market, the market that used to underwrite Germany's profitability, the collapse is even more dramatic. After spending 25 years as China's #1 automaker, Volkswagen was overtaken by BYD in 2024 and knocked into third place by Geely in 2025. Collectively, German brand sales in China fell by a quarter over 5 years to 3.9 million vehicles in 2025. Mercedes-Benz sold 551,900 vehicles in China in 2025, down 19% year over year. BMW delivered 625,527 units, a 12.5% decline. Both brands have now posted consecutive annual drops of more than 10%. Meanwhile, on the other side of this equation, BYD overtook Tesla in global EV sales in 2025, selling 2.26 million EVs to Tesla's 1.64 million. Analysts at UBS estimate that battery sales alone give Chinese automakers like BYD a $2,000 cost advantage per vehicle, and predict they will grow their global market share to 35% by 2030 from 25% in 2025. A $2,000 cost advantage per vehicle on millions of vehicles every year growing. This is not a competitive disadvantage. This is a structural engineering advantage that compounds annually. I want to be very specific about where Chinese battery technology stands right now in April 2026, because this is the engineering proof that should concern every person who still believes German engineering is the global benchmark. CATL, the world's largest EV battery maker, just unveiled a battery that charges from 10% to 98% in less than 7 minutes. 7 minutes. From nearly empty to nearly full. CATL and BYD together control more than half of the global EV battery market. CATL's share of global EV battery uses rose to 42.1% in the first 2 months of 2026, up from 38.7% a year earlier, growing every quarter. And here is the detail that makes every German automotive engineer deeply uncomfortable. BMW, Mercedes, and Volkswagen are all customers of CATL. The company that supplies Germany's batteries is Chinese, the most critical component of the electric vehicle, the component that determines range, charging speed, safety, and cost is being designed and manufactured in China. and shipped to Stuttgart and Munich. CATL worked closely with BMW to design battery packs for their early EVs. BMW had staff at CATL's facility to follow the manufacturing process. Germany went to China to learn battery manufacturing, not the other way around. And then there is this, published just last week. On September 14, 2025, BYD's Yangwang U9 reached 496.22 km/h at Germany's own automotive testing Papenburg Proving Ground, making it the fastest production car ever independently measured, surpassing the Bugatti Chiron, the fastest production car on earth, built by a company that didn't make cars until 2003, tested on German soil. Here is what I want you to take from this. This is not a story about China winning and Germany losing. This is a story about what happens when an entire industry bets its future on a wrong technology, combustion, and another player enters with no legacy, no sunk cost, no reason to protect old way of doing things. Germany built the most sophisticated combustion engine manufacturing ecosystem the world has ever seen. That was genuine engineering excellence, a real achievement, a century of real work. But the combustion engine is not the future of transportation, and the knowledge required to build the best combustion engine on earth is completely irrelevant to building the best battery, the best software architecture, or the fastest development cycle. China did not beat Germany by working harder or by copying. They beat them by choosing a different game entirely, one where a century of accumulated combustion knowledge was not an advantage. It was dead weight. Automakers once measured themselves against German engineering, Detroit's scale, or Japanese reliability. The benchmark now is China's rapid development cycles, software-first design, and low cost. The question for every car buyer in 2026 is simple. Do you want the car from the company that perfected the last century, or the company building the next one? My job is to make sure you have the information to answer that question for yourself. If this video changed how you think about the car industry, hit subscribe, because next week we go even deeper. The specific battery chemistry decisions that gave China its cost advantage, and whether solid-state batteries could reverse it. Drop in the comments. Do you think German engineering can catch up? I want to read every answer. See you next week.